Ini bisa saya mulai acaranya, Mbak Feb?
Bisa.
Okay. For everyone, those who has entered the room, we're about to begin. So please have a seat and make yourself comfortable. Good afternoon, ladies and gentlemen, to the Honorable Dr. Wan Nur Munirah Ariffin, as a senior lecturer and research fellow of Center of Excellence for Social Innovation and Sustainability from Universiti Malaysia Perlis, and a very warm welcome to the participant and student from STEKOM University. Is it indeed a pleasure to have all of you on this memorable occasion? And I would like to thank God for gathering us here in a sitting lecture program regarding business mathematics introduction to optimization technique in business application. Before we begin, please allow me to read our agenda this afternoon. First session class will be delivered by our guest lecturer, Dr. Wan Nur Munirah Ariffin. And finally, there will be a question and answer session after the presentation and continue with a brief photo session at the end. And we will start for this event today, ladies and gentlemen. I would like to remind all of the participants to turn off the microphone during the session. And then we will start for this session class today with Dr. Wan Nur Munirah. Yeah, for Dr. Wan, the time is yours. Thank you.
Thank you very much, Novita, Miss Novita from STEKOM over there. Hai, Assalamualaikum. Selamat petang semua. Nama saya, my name is Wan Nur Munirah binti Ariffin. And I do believe that there's a lot of Munirah in Indonesia, because in Malaysia, when I tell somebody my name Munirah, they always think that I was I hail from Indonesia. I don't know why. Probably in Indonesia, there's a lot of Munirah over there. Okay, thank you very much, Ms. Novita and STEKOM, especially to STEKOM and Center of Excellence, CoESIS, Universiti Malaysia Perlis, for this opportunity for me just to share with you about the optimization techniques. What the optimization techniques that we think that we can apply in business environment. Okay, let me please allow me to share my slide first over here. Share screen. Wait, yeah. Okay, this one. I really hope that every one of you can see my screen clearly over there. Is it okay?
Yes.
Okay, thank you. Okay, actually, for today's session, I would like to share with you what are the optimization technique, okay, and then which optimization technique that we think that we can apply in business environment. Usually, based on my personal experience, I found that there's a lot of research that business students do, especially in their final year project or during your final semesters. I do believe that most of you need to come up with a dissertation or a report regarding the research, the mini research that you need to do, okay, according to the problem that you try to investigate. Okay, and based on my experience, I found that there's a lot of research that business students do before. They just apply simple statistic, okay, regarding the correlation, and then they try to find, yes, we probably, they can find the correlation between the two variables, okay, and then they want to know further, okay, so that they do the regression analysis towards the correlation to find the strong relationship between the two variables. It could be the title of the research could be the impact, the effect, okay. So what I'm trying to show to tell you is that from my previous experience, I found that there is a restriction in business students in doing research. Normally, they just apply very simple statistical knowledge in their project, and then there's no such things that they try to do optimization, especially in business problem. Okay, so in my presentation today, I want to share with you what are the available optimization techniques. Actually, there's a lot of optimization techniques. Just for this session, I just want to spark to you the idea what is optimization technique, and then probably you get the idea on how you can try to relate with your business environment or business studies. Okay. All right, so this is my name, and I am the research fellow from the Center of Excellence for Social Innovation and Sustainability, CoESIS, and I can say that I'm quite amphibia, because of I am originally from mathematics, okay, engineering mathematics school, which is from Institute of Engineering Mathematics. And currently my research is more to business environment, where I applied some operational research methods, some optimization methods in business problem, okay, in few business problem, not overall, not all business problems I could understand very well, okay. So for specific type of problem, I applied, okay, some of the optimization technique, okay, in my research. So that are the things that I want to share with you today. Okay, first and foremost, we need to know what is optimization. If I try to reduce this slide to 55, 57. Can you see clearly, Novita?
Yes, Miss.
Okay, thank you. Okay, first and foremost, we need to understand what is optimization. Okay, so students and dear friends at STEKOM and also in UNIMAP, optimization by definition, there's a lot of definition. I want to share with you, there's a lot of definition of optimization. Okay, first, optimization by definition is actually an action or an act, process and methodology of making something, such as, for example, you try to design a system or you try to make a decision. Okay, you are a decision maker, you try to make a decision. Okay, so it could be an act, process, methodology. Okay, as fully perfect, functional, or effective as possible, especially it also requires or it also involves mathematical procedure. Okay, procedure. Okay, and then do you know that optimization started its gradual perfection in mid of 19th century when it was derived from the word optimize. Okay, so what is meant by optimize? Okay, optimize means that to make the best or most of. Okay, and the word optimization comes or derived from the Latin optimus, which means best. Okay, so from these two definitions, the idea could be optimization. It means that we try to find something best, the best or most of, and it requires mathematical procedures. Okay, so that is the two ideas regarding optimization based on these two explanations. So we go to this one. what are they said about optimization? In mathematics, computer science, economics, or management science, mathematical optimization, or sometimes it is called as just optimization or mathematical programming, is the selection of a best element with regard to some criteria from some set of available alternative. In the simplest case, an optimization problem consists of it is either maximizing or minimizing a real function by systematically choosing input values from within an allowed set and computing the value of the function. Okay, so this ini, okay, here we have the idea of optimization. It has a lot of application in many disciplines. It could be in mathematics, it could be in computer science, it could be in economics or management science. Okay, so optimization is a process to find the best or the most optimal. Okay, and we need to select the best element. Okay, from the set of available alternative. Okay, and the process consists of either maximizing or minimizing a real function. Okay, so that is the idea of optimization. Okay, this is something that we try to simplify. What is mathematical optimization? Okay, mathematical optimization is a field of applied maths that seeks to find a combination of input variables that maximizes or minimizes the output of a return of a multivariable function. So what I can conclude from the optimization is that I do believe that you already heard about a set of function, minimize, maximize, a set of variables, okay? So that are the things that we need to consider when we try to apply or when we try to read or when we try to use the optimization technique, okay? All right, so what does optimization mean in business? Okay, so in business, optimization is the process of fine-tuning a business strategy or a process in a business in order to improve efficiency, or we try or we attempt to reduce costs. Okay, of course, in business, we try to reduce costs, we try to maximize the profit. Okay, so that are the things that we call it as the normal vision and the normal the usual thing that we always do in business: reduce costs, maximize the profit, right? So that is one of the optimization problem. Okay, that is optimization problem. Not we didn't go to the, we don't go or we don't jump into the optimization technique yet. Okay, this can be done by using resources more efficiently, cutting costs, or investing in labor-saving technologies. So, by integrating the information that we have just now, okay, which are the variables, minimizing, maximizing, a set of constraints, and so on just now. So, in business, the idea is that we already have the goal. Okay, we have the goal in order to either to reduce the cost or maximize the profit. So that is the way to improve our business efficiency. Okay, so in order to make sure that we can get the optimal results, okay, the optimal cost or the optimal profit. So by doing or by using the optimization technique, okay, so what we need is probably we need to consider the resources that we have, okay, the cost that already incurred in the process, okay, and etc. Okay, so that are the things that we of course we have the goal or the objective. Okay, it is either to minimize or maximize, and then what are the constraints that we have in order to make sure that we can reduce one by one in such a way that we can reach, or we can get, okay, the goal, that the desired goal. Okay, so that is the optimization in business. All right. There's a thing in optimization is an important process in maintaining a business or trading system. When we talk about a trading, I'm not the one who are expert in trading, but I try to read. There's a lot of things regarding the trading. Okay, but until now, I what I can share with you is I'm not expert in that kind of thing. Okay, but optimization technique also used in the trading system. Okay, by adjusting system parameters to reduce costs and maximize the output, optimization allows business and trader to become more efficient and competitive. So normally, many people talking about optimization in business. Optimization in business. Optimization in business, the optimization problems, and the optimization technique. Okay, so there's three things that we need to understand very well, because of each optimization problem requires specific optimization technique to solve. Okay, not every single optimization technique applicable to all optimization problems. Okay, I hope that everyone is okay in STEKOM. If you guys okay, click okay. All right. So how an optimization works. Okay. This one is about the traits. I don't want to talk more on how the optimization work. Let me jump to the the variables or the vocabulary that we always use in optimization. Okay, as you can see, I share with you right now is about inputs and outputs. Okay, in simple term, optimization is about choosing the inputs, which results the best output for making things the best they can be. Okay, choose inputs which give you the result, which is your output. Okay, and the results must be the best. Okay, the best things that you have, that you obtain. Okay, so that is optimization. If you get the result which is not optimal, the optimal means the best. Okay, in mathematics we call it the optimum. The optimum is the best. Okay, if you didn't get the optimal result, it means that probably you are making bad decision. Okay, if you get not optimal result, okay, by using by defining your variables, by setting your goal, okay, probably you get the inoptimal result. And finally, when you use that kind of result, it means that you are probably doing not good decision. Okay, all right. So now, the optimization can be a variety of things. Okay, so I put here about the allocate, the word allocate, the word design, and the word control. It could be deciding. Okay, we try to decide the most effective allocation of available resources. For example, okay, I just try to share with you. This one is the normal or the usual, okay, the most of the time we use this kind of terms or vocabs, okay? Allocation, for example. As I mentioned to you, we try to decide the most effective allocation of available resources. For example, you have a supermarket, okay? You have a supermarket, okay? Of course, you have lot of things or goods that you sell to your customer, okay? And then you find that at one time you has put the order, which is the order of the goods is actually more than enough. It is what we call it as barang yang di order itu berlebihan, okay? Berlebihan daripada sepatutnya, okay? So now the optimization technique, the specific optimization technique can be used or can be implemented in order to allocate which product, okay, which product to which shelf, okay, to which product should be assigned or should be allocated to which shelf in such a way that there are no products or there are no goods, okay, which is in your stores, okay, and everything are allocated or assigned on your shelf. So there's a lot of optimization technique that we can use, and and at the end of this sharing session, inshallah, I will share with you what are the techniques that you can apply, that you can use, that probably you can try to investigate in order to come up with new idea in your research, in your papers, okay? And then the word design, okay? Design, for example, with producing the design with the best characteristic that you think that is the best characteristic. So that is one of the optimization. Okay, and the last one is control, choosing the control variables to make the system behave as desired. Okay, so that is the terms that we frequently use, okay, in optimization. And also, okay, talking about the maximize and minimize, these two words, okay, will act as your goal, your big goal, okay, in the problem, which is we attempt to maximize or minimize. So maximize and minimize, of course, you know, maximize is you try to maximize something, and minimize is the process to minimizing something, okay? Right. What are the possible application of optimization? Okay, first, probably in the warehouse placement, where we try to, for example, choosing the optimum location, okay? Choosing the optimum location of the warehouse to minimize the shipment time. So this is one of the optimization problem, okay? And it also applicable to the strategy games, where we try to choose an optimal build order in strategy games, okay, to maximize the number of strongest army as possible in a given time. So we have the restriction here is time. Okay, the constraint is time. We try to maximize the army strength. Okay, so the problem is to choose, the variable is to choose the build order here. Okay, then another thing is about the design. Okay, the design of airplane. Okay, this is something like we try to design a wing of the airplane, okay, in such a way to minimize the weight. Minimize the weight is the goal, okay. And at the same time, we want to maintain the strength of the wing, okay. Okay, so this is one kind of the optimization problem. Okay, last but not least here, I just choose 4, okay. Actually, there's a lot of application. So the 4th application that I choose here is about the stock market. Okay, selecting the best stock to invest to maximize the returns, okay, based on the predictive performance. So this is one of the application, and probably in business, you are as a business student, I do believe that you are very familiar about this one. Okay, so as a conclusion to the sharing session about the optimization, okay, the definition of optimization, the vocabulary, okay, or the words that we frequently use in optimization, as well as some application of the optimization. What I can share with you as a conclusion to that one, to the first part, is that optimization, okay, helps to find the inputs that give the best outputs, inputs and outputs, and usually it is the optimization usually requires an optimization algorithm. Okay, optimization, or also known as mathematical program, is a collection of mathematical principles and methods used for solving quantitative problems in many disciplines, including just now we have in engineering problem, we have in economics problem, business problem, physics problem, and so on. So basically in this session, when we talk about optimization, optimization problem, optimization technique, optimization algorithm, actually we are talking about the quantitative problems. Okay, quantitative problems. Okay, so next. Okay, in optimization, okay, in optimization, apart from this one, maximize, minimize, allocate, design, control, there are 2 terms that we use, okay, especially when we talk about optimization, especially normally you can find these 2 definition, these two terms in linear programming. Okay, so the first one is objective function, and the second one is the decision variables. Okay, so what is objective function? Objective function, just now, as I told you earlier about the minimize and maximize, minimization and maximization problem. Okay, we try to minimize something, we try to maximize something. Okay, so in mathematical written form, okay, so we normally write as minimize fx. Our f is the objective function, okay, while our x we will discuss after this. Okay, so objective function is actually the value, okay, the value that we are trying to optimize. Okay, the f, we are trying to optimize this f. Okay, normally in mathematics we write it down as f. Okay, it could be in any kind of terms that you try to represent after the minimize word, okay, or maximize. Okay, for objective function, as I told you just now, is about goal. Okay, goal. Okay, the value that we are trying to optimize. Okay, minimize waste. We try to minimize the number of waste collection. Okay, within a week. Okay, in our residential, for example, we try to minimize the cost of we try to minimize the cost of fuel, okay, for the garbage truck to collect the waste, okay, from residential A until residential F, for example, okay. And then we try to maximize the speed, okay, in such a way that we can reach arrive at a specific target, okay, in the very minimum time, okay. And of course, maximize the speed in order to reach our target in a very fast way, okay, a fast time, for example. For profit, for example, of course, I do believe that every one of you are very understand, and you know that for profit, of course, we try to maximize the profit, okay, in such a way that probably we try to reduce the constraint A, B, and C. So the goal, okay, the things that we are trying to optimize, for example, we try to maximize the profit can be achieved, right? So next, this is about the objective function, and the second term that we use is decision variables. Okay, what are the decision variables? Decision variables, just now we know about the inputs and outputs, right? So the decision variables is actually the inputs, okay, inputs to our problems that our optimizer would like to change, okay. So this one, the definition, values the optimizer can change, okay. So the same thing, the inputs to our problem that our optimizer would like to change, okay. Sometimes we call it as decision variables. Sometimes you hear that somebody talking about manipulated variables, or sometimes people say about decision variables. These three things means the same, okay. Decision, manipulated, or design variables, okay, the same thing. Okay, next. All right, so for the second part, I shared with you about the two definitions, about the two terms, okay, two terms that we frequently use in optimization, especially in linear programming. For those who are very familiar to linear programming, that is one kind of optimization technique, for the quantitative technique, also known as the optimization technique, okay. The first one is objective function, the value that we are trying to optimize. It is either minimize or maximize. And then the second one is the decision variables, which is the values the optimizer can change. And also decision variables, also known as design variables or manipulated variables. Okay. All right. So this one, we go to the optimization technique. Is every one of you okay over there? Novita and friends over there, are you okay?
Yes, Miss.
Okay, so let me proceed, okay? Boleh ya? All right, everyone. Just now we talk about the optimization, definition of optimization, and we already been presented about the some application of optimization, okay, and then the vocabulary or the frequently used term that we use, okay, in optimization. And now we are talking about the optimization technique, okay. So normally for optimization technique, it could be the classical ones and the method which use the soft computing. Sometimes it is called as soft computing, okay. Other few methods, okay, in optimization that they call it as soft computing. All right. In this session, I just want to spark the idea on a little bit on few optimization technique, okay. But before that, I hope that every one of you who are not very familiar with these four techniques or method, probably after this you can try to check on the Scopus or WOS database. Okay, there's a lot of research currently on business application which use the fuzzy logic, especially in economy, if I'm not mistaken, fuzzy logic in economy. And then they use also the neural network in business. Okay, this is to get the best decision before they want to do the decision. Okay, the best decision as a manager. So normally they use the neural network first, okay, to get the initial decision, right? The next thing is about evolutionary algorithms. There's a lot of algorithms from evolutionary. Okay, evolutionary algorithms. There's a lot of algorithms from Evo actually. And last but not least is the theory of chaos. The theory of chaos. From my readings, I found that the theory of chaos probably used in economics also. Okay. All right. From here, the optimization technique, I want to just park the idea on the linear programming. If you still remember, this is what we call it as the basic, very basic but powerful, okay, powerful technique, okay, powerful technique in order to make a decision. Okay, so this is one of the quantitative technique. We call it as the optimization technique also. Okay, as I shared with you just now, we talk about the objective function, okay, and the variables just now, okay. Okay, we have the manipulated the decision variables and the objective function. So I want to share with you this problem. Okay, a carpenter makes bookcases in two sizes, small and large. Okay, bookcases in two sizes, small and large. It takes 6 hours to build a large one, 6 hours to build a large one, and 2 hours to build the small one. The profit from the large bookcase is $50 and the profit from the small bookcase is $20. $50, the profit, this one is also the profit. The carpenter can spend only 24 hours a week. The constraint here, the carpenter can only spend 24 hours a week making bookcases and must make at least 2 large and 3 small each week. Find his maximum profit per week. Maximum profit per week. So this is, we're talking about the optimization problem. Okay, so just to spark the idea, just to revisit what is linear programming. Okay, to all of you. Novita, are you from business program, Novita?
No, actually, I'm from computer system department, Miss.
Oh, okay. So that is interesting. So probably you can understand very well the techniques after this. Okay. Thank you, Novita. Okay. So I think from the computer school, okay, also has been introduced this linear programming, okay, very basic method, yet it is very powerful. Okay, so we try to define the variables that we have. Okay, the variables is probably we have the bookcases, right? Bookcases, small and large. Let me just say that L is the number of bookcases. Large bookcases that we build, okay, that the carpenter built, and then the small one is the number of small bookcases that the carpenter built. And then we try to obtain the objective function. The objective function, okay, that is our goal. Okay, our goal is the profit, the goal here is to find the maximum profit per week. Okay, so it could be the objective function regarding the profit also. Okay, so now we could find that the objective function is like what? Maximize. Okay, we try to maximize the profit. Where the maximize the profit, they have this one. Okay, maximize, for example, it could be maximize fx, or sometimes you can write down as maximize z. Z is your objective function now. Okay, maximize z, which is 50 of large, right? And then for small one is 20L. Sorry, 20S small. Okay, and then we have the objective function. The objective function could be apa lagi yang kita belum guna? Okay, this one 6 and 2, right? So 6L plus 2S. Okay, 6L 2S regarding its the hours taken to build the small and the large bookcases. And then this is restricted to 24 hours. 24 hours only. 24 hours only. Okay, the objective function, this is the objective function and this is our constraint. Okay, so alternate, terbalik sikit. Okay, so the constraint should be 6L plus 2S, okay, less than or equals to 24 hours per week. And it could be more than one. Apa lagi kita nak letak dekat sini? 22 large. Okay, 2 large and 3 small. So the L must be greater than 2 large, okay, and then your S must be greater than 3. So in linear programming, this is how we define the objective function. We define the variables first, then we have the constraint, and we have the objective function. Okay, so the objective function now is to maximize our profit. The maximize Z equals to 50L plus 20S. Okay, and then our constraint here, we have 6L plus 2S less than or equals to 24. It cannot be over 24 because the carpenter can spend only 24 hours per week. Okay, and then the bookcases must at least has 2 large and 3 small. Okay, so these are the constraint and objective function. And normally in linear programming, if you still remember, okay, we will write it as what? Maximize our Z, which is our objective function just now, and then subject to all the 3 constraints and make sure that the variables cannot be negative. Okay, so this is what probably you already been introduced about the optimization technique. Okay, I already learned about the linear programming, but I don't know that this is one of the optimization technique. Yes, linear programming is one of the optimization technique. So if you try to use this, we call it as the tools, okay, to solve this kind of problem. You can solve the linear programming, the linear problem like previously, okay, that presented here. Okay, you can solve it manually, or you also can solve it by using the we call it as a package, okay, computer package, okay, or the solver, okay, to solve that kind of problem. I already shared with you right now is the QM for Windows. Did you see that? Did you see here the programming here? Everyone, anyone? Share. Okay, this one Windows. Okay, this one, right? So normally we try to solve this kind of problem by using the software, So probably you can choose the linear programming, okay, put the title, okay, book cases, for example, and then we have 3 constraints, okay, the number of variables are just S and L, right? And the objective function is either minimize or maximize, so we try to maximize. Okay, so there you go. Okay, so we can put all the necessary information here. For example, okay, the objective function is 20L, 50L and 20S, 50 and 20. Okay, and then the constraint 1 is, constraint 1, what just now? Constraint 1 is 6L, which is X1. And then we have 2S, okay, which is X2. And this is less than or equals to 24 hours per week. And constraint 2, we just have the large should be greater than 2. So this one is 1, and the right hand side should be 2. And constraint 3 is small, which is X2 equals to 1. Okay, the coefficient of S just now is 1, and then it should be greater or equals to 3, this one, like this. Okay, we just play around with this one. Okay, then we try to solve the problem. Okay, so we got this one, 200, the solution should be 220. And then you have the linear programming result. It's either to graph it, okay, in the form of graph. Okay, and there's a lot of things that you can read from the software packages. Okay, so there's a lot of things that you can discuss. Okay, there's a lot of things that you can explain to the to your lecturer, to your manager, okay, regarding the optimization problem, okay, based on the constraints that you already put here and the problem that you're trying to optimize. Okay, let me show you this one. Okay, I am currently moved to the PowerPoint slide. Are you now watching the PowerPoint? Novita?
Yes, Miss.
Okay, PowerPoint, right? Okay. Okay, ladies and gentlemen, I also find that fuzzy logic is also used in economics. Okay, so I found that this one, the theory of fuzzy set and fuzzy logic were developed to enable the process mathematically linguistic terms. Fuzzy models may help in making decisions. The application of fuzzy logic results is in practice relatively voluminous. Firstly, describe the theoretical background of fuzzy sets and their basic operations, and then the fuzzy model of automated safety, considering the vehicles, its manufacturer, and intelligent transport system, ITS, is constructed to demonstrate how fuzzy set help to make thoughtful decisions on purchasing. Okay, so this is one kind of application of fuzzy logic. Okay, I don't want to discuss very specific, okay, the variables, how the method works, okay, about the fuzzy logic. If you have if you would like to learn more about the fuzzy logic, or you have a problem, okay, in economics, for example, or in any business application, and you find that you need an expertise, or you need an expert from fuzzy logic, probably you can contact UNIMAP, okay, then we can do collaboration, because in Institute of Engineering Mathematics, we have more than one physiologic experts, okay. All right, for the second one is, okay, this one, I've read, okay, a journal regarding application of a fuzzy set and a fuzzy logic to economic problems, study literature review, and this one is from journal, study literature review of journal, okay. So these are the authors: Suripa Zetriuslita, okay, Department of Mathematics, Universitas Islam Riau, Pekanbaru, Indonesia. So probably if you would like to know more about the fuzzy set, fuzzy logic, okay, to economic problems, okay, probably you are from business or economic faculty, and you would like to jump into a new and current technique, current methods that we use, okay, especially in your specific field of study. So you can contact people from the mathematics department also. Okay, so next. The next is about the N colony algorithm. Okay, I found the actually N colony algorithm is an old method or an old algorithm. Okay, this is one of the optimization technique also, okay, that we currently use, that we actually for a long time ago we already used the N colony. Actually, we have also B colony. We have Wales algorithm. Okay, Wales. N, bee, wolf, crows. We have also cuckoo. Okay, we have a lot of animals. Okay, actually we have a lot of animals. The algorithm are built based on their behavior, natural behavior. Okay, so the mathematician try to implement the algorithm based on the behavior to that certain or specific targeted problem only. So I found that one paper regarding the core business selection. Okay, the core business selection based on the N colony algorithm. Okay, so in this paper, if I'm not mistaken, this paper is taken from Hindawi, okay, one of the prestige journal publisher. Okay, so this paper regarding to find the characteristic of core business, and then it tried to find the index. Okay, it tried to find the index of core business selection. Okay, and then finally, the decision maker could make a good decision. Okay, unfortunately, I found that there is still open problem regarding the selection of core business by using the N colony algorithm. Probably, if you are interested, try to find this kind of paper, and probably you can try to implement, okay, to implement or to identify the decision variables to make a better decision or to improve this kind of paper. Okay. Right. The other thing is, just now we are talking about N colony, and this time we are talking about the genetic algorithm. Okay, the genetic algorithm is one of the optimization technique also, okay, which is used to forecast the financial markets. Okay, so genetic algorithm, okay, genetic algorithm actually works, okay, by performing the crossover. Okay, it could present the mutation, and the last one is selection. Okay, there are three important terms and three important things could exist in genetic algorithm, because genetic algorithm is based on the genetic operation. The first one is crossover, the second one is mutation, and the last one is the selection. If you want to talk about these three things, and and then after that, the operation, which is include the five operation, okay? So, or five processes. I do believe that we don't have too much time talking about the genetic algorithm. Genetic algorithm is also one of the powerful technique, okay, in optimization. And normally, right now, there's a lot of optimization technique which hybrid with the genetic algorithm. Okay, sometimes we found that genetic algorithm with, for example, the partitioning technique, okay, in order to solve some kind of problem. As I mentioned to you, the optimization problem and optimization technique, okay, each optimization technique will apply to certain type of optimization problem. Not all optimization technique can applicable or apply to every single optimization problem. Okay, so my student is currently investigate the genetic algorithm and try to hybrid with the partitioning technique to solve for allocation, to allocate or to assign the product to shelf, a product to shelf. Okay, this kind of mouse with this certain specific dimension should be placed in this level or this level, within this kind of height and with it certain width. Okay, so we are talking about the optimization problems in order to help the business or the business owner or entrepreneur to design the best layout, okay, to design the best layout of shelf in their store, such a way that it is easier for the buyer or to the customer to select or to choose to pick up the products, and at the same time to make sure that all the products are on the shelf. Okay, so that is the current problem that we investigate, okay, by using the optimization by using the optimization technique. Okay, all right. The last thing that probably I want to share with you is regarding the optimization problem, which is to optimize the product selection. Okay, this research has been conducted for two years. Okay, which is actually this is one of the problems in business environment. Okay, in business. Okay, in nature, but we attempt to use the mathematical method, okay, which is the optimization technique, okay, based on the graph network analysis and clustering, okay, in order to find what are the best product should be packed together in such a way that when you as the business owner or anything related to business, okay, when you try to do promotion, you know what exactly products should be packed together and sell it to your respected customers. Okay, let me share this one. I share screen is no right. Okay, this one lah. Okay, Bismillahirrahmanirrahim. Okay, this one. Okay, so just now I was talking about the optimization technique, okay, in choosing the best product, which product should be packed together, which product should be sold together, okay, in such a way that when you are doing the promotion, all the products, especially the slow-moving products, are removed, okay, from your shelf. Okay, so actually that is the optimization technique from the mathematics, okay, which we apply to the problem in the product category management in retail industry. for people from the management or from the marketing field of study, I do believe that you know already about the category management, okay, or product category management. So I don't want to explain very much here. Okay, so what actually we do, okay, what we actually do, okay, by using the optimization technique is actually we call it as the product network analysis. Okay, product network analysis in category management, product category management. The first one is we know that products belongs to the same micro category, and then it try to create the category loyalty, okay, cross category sales and rationalization opportunity exists. And now, okay, in order to solve that kind of problem, okay, the idea is that we as the consumer, as the customer, when we buy anything, okay, from a shop, of course, that kind of shop have the transaction, okay, data transaction or the purchasing transaction, okay, from us, okay. So they have the sales item, okay, and all the information are inside the computer, okay. So from the customer data transaction, we actually, what we can study is that we also can study the customer or the consumer behavior based on their purchasing behavior, and then we want to discover the relationship, which is we try and finally we try to maximize the total revenue. Okay, so that is the what we call it as the objective function, that the objective of this study and the constraints that we have. Okay, so now in one particular retail company or retail industry, of course, there's a lot of division, and the products are categorized by their own category, and it also has its subcategory, okay. And we have the consumer data, consumer transaction, and then as a mathematician, okay, for those who are already familiar with machine learning, these transaction can be easily transformed into a data set very easy, okay. And then me, myself, and my team, okay, work together to represent this kind of data in the form of graph network, okay. So in mathematics, we have the graph network analysis, okay, which is we try to optimize that kind of products, okay. This one, not this one, okay. So actually, okay, from that kind of let me share this one first, sorry. Okay, share. Okay, this one. Okay, I got this one from my previous supervisor, okay, which studied on the click, okay. The click means that in business environment, we can see that the click is, okay, in mathematics, for example, when you have a strong relationship means that these nodes, okay, number 8, number 7, number 19, number 31, number 27 is actually, we call it as nodes, okay. And the link that connect 27 and 8 here, okay, 8 and 7 here, you have the link that connect to each other, right? So we call it as the relationship, okay. In business, probably the relationship could be the number or the volume of purchase, okay, that the consumer did for that kind of products, okay. It could be product 27 has the connection or relationship with product 8, okay. Probably 27 is actually a shampoo and product 8 is actually a conditioner, okay. So normally in a week there are 300 number of customer or consumer who buy product 27 and product 8 together. So that is why we have the relationship here. Okay, so now what we did in our research is that we try to identify the group, or we try to cluster this kind of products. Okay, so when we cluster the products, when we categorize the product, we can say that the first group here, which is 48 until 46, probably this is one of the group which is the fast selling product. While the last one, 44, 6, 36, 38, 46, and 50, these kind of products, we call it as the slow moving products. So when you are trying to do the promotion, you know which product or what product should be choose, which product should be packed together in order to make sure that the the slow moving products are eliminated from your shelf. Okay, so at the same time, you can maximize your sales, your profit. Okay, so this is one kind of the optimization technique that we use, where we combine the graph network and then the partitioning technique, okay, in our research. Okay, this is one kind of the research which help the retail industries, okay, in order to minimize the slow moving products. Okay, and finally, at the end of the research, probably, okay, the industry or the retail industry could determine what are the core product, what are the pair product based on the purchasing behavior of each of their outlet. Okay, not all outlets have the same purchase behavior. Probably in outlet A, product B is the slow moving product. Okay, probably in outlet C, okay, product W is the slow moving product. So the slow moving products, and we try to determine the type of product is actually based on the purchasing behavior according to your specific place. All right, so from the research that we did, okay, the benefit to the retail industries is that you can identify the core product and what are the pair product, and later on, you can identify, you can set the core product, okay, should be sold in retail price or in markdown price, or the pair product can be sold in retail price or the markdown price. So at the end of the research, finally, we propose to the industry, okay, if you try to do like this, okay, so what is your what we can predict, we can do prediction, what is your total profit at certain period of time. Okay, so that is what mathematicians do, and the mathematician itself, themselves cannot do this alone. Okay, the mathematician need, okay, we need somebody from the industry, somebody from business, somebody from the marketing field of study, in order to make sure that what we did is true, what to validate that what we are doing right now is right. Okay, so the combination of experts, okay, in doing this kind of research is a must. Okay, next, let me share one more time on this one. Which one? Okay, this one, right? Okay, so that is what we did. Okay, what my team and of course myself did on the optimization on product selection. Okay. There's a lot of optimization techniques and algorithm available. Probably you can find it from this website. From this website, it tells you, okay, this website is telling you the type of algorithm technique and optimization technique and optimization algorithm, and the specific problem that the optimization technique can solve. Okay, so please try to find from this website, and then you get so much idea from this. Okay. All right. So I think, Novita, that is the end of my sharing session. Thank you very much.
Thank you very much for Dr. Wan
Yeah.
for excellent presentation. And then we will go to the next session, question and answer session. For our audience, if you wanna ask question, you can raise your hand or you can write in room chat. Thank you. Okay, I will read first question in Zoom chat. This is from Mr. Amin Tohari. What are the three main components of mathematical optimization according to you? To your alone? Thank you.
What are the main three components of mathematical optimization? Okay. The three main components in optimization, of course, the first one, you must understand very well what are the problems that you are trying to solve. Okay. What are the problems that you are trying to solve? The first one, you must very clear of what is your problem, which is the problem statement itself. When you are doing a paper or some a report, this is what we call it as a problem statement. Okay. Otherwise, in this kind of optimization problem in mathematics, first of all, you must understand very well what you are trying to solve, and the second one is try to identify what variables or what constraints that you have. Okay, and then the third one is try to formulate. Okay, according to the variables that you have. Okay, formulate all the constraints and set the best objective function that you're trying to optimize. Okay, so that are the main component when you are trying to do optimization in mathematics. Thank you, Amin.
Okay, thank you for answering. And then the next question, what are the requirements for solving linear programming problem using the simplex method, and why should we use the simplex method in the case of linear programming? This is question from Muhammad Faiz Sahrudin. Thank you.
Oh, from the simplex. Okay, just now I didn't show you the simplex method pun. Okay, in linear programming, or probably in linear programming for simplex method, who is just now?
Pardon?
Fabriana. Okay, so probably you can contact me. Who is just now talking about the simplex method, because I cannot find it here.
Muhammad Faiz Sahrudin.
Faiz, just text me after this, Faiz. I will show you very well on how to solve the linear programming using the simplex method. Okay.
Yes. Okay.
Okay. Actually, just now I just show with I just sharing about the use of POMQM, okay, software. Actually, there is one more software package which is more simpler, which is we call it as Tora. Tora, during my undergraduate studies back in 2005, I already used the Tora. Until now, I use Tora. So if you could find, you just download Tora. It is a free software. Try to download Tora and then try to explore it. And inshallah, if you have any problem regarding the Torah, and try to email me, inshallah, I will help you, especially to Faiz. Okay, Faiz, thank you very much because you are interested in linear programming, Faiz. Mr. Faiz, right?
Yes, thank you so much, Dr. Wan. And then the Yeah, maybe for our audience in Zoom chat for now, you will raise hand. Okay, I will continue to the next question. This is audience from the YouTube. Okay, from myself, I am very interested in trading or some kind of investment. And discuss we can know the basic of trading from business mathematics lesson. But in our country, trading is still a strangers to the general public, and I have no relation to learn about this. Is it anything can Dr. Wen recommend for me? What should I learn first? This is question from Miss Sukamto. Thank you.
Okay, actually, as I mentioned to you just now, I am not the one who are expert in trading. Okay, I'm not the one who are expert in trading. The combination of mathematician, okay, me as a mathematician, and the traders or somebody from business who are expert in trading, actually we need to pair together in order me myself to understand what's going on the trading, and then from there the mathematician can look at what are the appropriate technique in order to do some kind of optimization in the trading. Okay, Novita? Okay. First of
Yes.
all, we must understand very well the trading, what they use, what they do in trading, and then then only the mathematician got the idea on the optimization technique.
Okay, thank you so much. Yeah, maybe from audience in YouTube, no more have question again. Maybe from audience in Zoom, you will ask question again. We will waiting for 1 minute again. Oh, okay. I I guess no one else asking again. May I continue to the next session? Time for picture, Miss.
Sure.
Yeah, so for Miss Febri, you can handle it.
Mbak,
Wait. Mungkin ini Bapak Hengki ingin bertanya?
Saya nampak Bapak Hengki angkat tangan ya.
Oh iya. Oh ya, sorry Miss Febri ya. For Mr. Hengki, the time is yours. Thank you.
Okay, thank you for the chance. Can you hear my voice?
Very clear.
Okay. Thank you. Very good afternoon to Prof. Wan Nur Marina. I'm glad to have your presentation. My question is, did you include organization behavior on the topic? How it works? That's the first question. And I have another question after you respond. Thank you.
Yeah, thank you. The first one is actually I just jump into the optimization and combine it together with the business problems. Okay, actually this problem doesn't include OB in too much OB or OB knowledge in our research specifically. Okay, we just find out from the as I mentioned to you just now. Okay, we just learn, okay, from the data transaction, and we translate it which product give the most or the highest volume. It means that people like the product. That is the assumption that we do. We do not involve, or we do not include any OB in our study yet, Pak Hengki.
I see.
If you OB,
maybe Prof. Nur can give the reason or the clue why in this case you didn't put OB in the presentation. Thank you.
Okay, insyaAllah, Pak Hengki, thank you for the idea. Inshallah, Pak Hengki, because of there are about 5 to 6 number of people in our research team solving this kind of problem, but none of them are from the business studies. Okay, which is recently we accept one from the business, which is from the marketing field of study. So probably the marketing point of view is different from the OB people. Are you agree with my statement, Dr. Hengki?
Yeah, sure. It doesn't matter. On the other hand, maybe you can inform us here as a participation. What is the dominant factors in the material that you present today? Maybe you can describe it. Thank you.
Okay. Yeah, thank you. The idea of sharing session today is to spark the idea on the optimization technique, which can be applied probably in the business studies. Okay, so what I have shown just now is that probably the current research that we do in here is we implement, okay, we use the strategy of optimization technique from genetic algorithm and from the mathematics part, okay, and then we combine or hybrid it with the partitioning technique, which is from the graph network analysis. Then we try to help, okay, we try to help the company in order to find which product to be allocated or to be assigned at a specific shelf or rack at their business or at their store. So that is one of the idea, Pak Hengki.
Okay, thank you. Maybe last question. Maybe you have a note in a certain situation that this will be happen to the business. Thank you.
Yeah. Thank you, Pak Anggi. Yeah, actually, I am not from the business side. Okay, I am, as I told you just now at the earlier of my presentation, I am the mathematician. I'm coming from the Institute of Engineering Mathematics, which we apply the mathematical techniques, especially for quantitative problems. Okay, quantitative problems, to help the business people to go out from the very simple statistical methods, okay, to solve some kind of problem in business. For example, they just studied on, normally from my experience, studied on the impact, the effect, okay. So it is just to study the relationship between 1 to 2 variables or more than 2 independent variables, right? So they just used a very simple statistical technique, okay. In fact, in business, they can do more than that, okay, beyond than that. So that is why the optimization method or optimization techniques could help, okay, in business environment. The problem is that, okay, we need, as a mathematician, we need to understand very well, and we must have a very good fundamental from the business perspective. For example, like your idea just now, do you include OB? Okay, if we include OB, I do believe that this research could be wow, better than now, right? So the research could be more impactful. Thank you very much, Pak Hengki.
My pleasure. Okay. I return back to Ms. Brianna and Novita. I'm standing by. Thank you.
Thank you.
Thank you for Mr. Hengki. And then we have a second question with Resen, Mr. Adi Nugroho. Yeah, for Mr. Adi Nugroho, the time is yours. Thank you.
Okay, Ms. Novita, can you hear me?
Yes, sure.
Okay, I would like to ask you about the variable of the the equation of the algorithm, because from what I see, it's just like a decision support system in the in information technology education. It's called decision support system in the fuzzy logic. Okay. My question maybe is just a simple question. How much data we need to make the calculation reliable? Just like statistic, we need at least 30 data to make the data is normalized. What if when we apply this fuzzy logic algorithm on the marketing environment, how much data should we need at least to make the decision reliable? Okay, that's my question. How much data we need?
How much data that you need?
Yeah.
For fuzzy logic, to be honest, I'm not very sure on how much data that you need. Okay, but back to the what we call it as the statistical point of view, at least we must have n equals to 30, right? In order to
Yeah,
show that
okay.
our problem, our decision is right. Okay, so in fuzzy logic, I'm so sorry, Mr. Adi, because I cannot answer the question in a good way, because of I'm not very sure what is the at least number of n that we need in order to get the good decision by using what we call it as just now, a fuzzy logic. Sorry, I'm
Yeah.
so sorry, Mr. Adi. Probably after this, I try to find out what is the minimum number
Minimum.
of
Okay. Yeah.
study.
Yeah, that's my question. Yeah, that's already my question in the very long time, because how much data we needed to make just like this kind of system reliable. Okay, thank you for the
Thank you,
answer.
Mr. Adi.
Yeah.
Thank you so much for Mr. Adi. I guess no one else asking again. May I continue to the next session? Time for a picture for Dr. Wan. Yeah, for this session will be handled with Miss Febri. Thank you.
Okay, thank you, Miss Novita. For those who haven't activated the camera, you can active the camera first so we can take photos together. Ya, bagi yang belum mengaktifkan kameranya, bisa diaktifkan terlebih dahulu agar kita bisa foto bersama. Baik. Okay, let me count from 1, 2, 3. Once again. 1, 2, 3. Okay, thank you. I will return the event to Miss Novita. I'm sorry, Miss.
Okay,
Mute.
thank you. Thank you so much for Dr. Wan. I think it's a very clear answer from Professora. Finally, we come to the end of visiting lecture today. We would like to say thanks again for Dr. Wan Nur Munirah for their wonderful information. Thank you for sharing your knowledge, and we hope this information will be beneficial for our audience. And I hope we can meet again in another event in the future. Also, I would like to thanks for all participants for attending this visiting lecture today and making this even more interesting. At least we hope to have more collaboration in the future. The visiting lecture today for today ends here. We hope to see you soon. Thank you and see you and have a nice day.
Terima kasih semua ya, Pak Adi, Dr. Adi, Anggi, dan semua Novita and friends. Thank you very much.
Thank you so much for Dr. Wan.
Thank
See you
you,
soon
Dr.
in the
Wan.
You're
future.
welcome.
Bye.
Thank you so much.
Bye.
Thank
Goodbye.
you, Dr. Wan. Baik, bagi peserta yang belum absen, bisa absen terlebih dahulu Bapak Ibu ya.
Oke, terima kasih. Bu
Absen
Febri.
sudah tertera di kolom chat.
Terima kasih Bu Febriana.
Sama-sama Pak Hengki yang selalu hadir di webinar kami.
Insya Allah kalau tidak ada meeting atau ada kelas ya saya hadir. Oke, izin leave ya.
Baik,
Terima
Pak.
kasih. Terima kasih semua. See you soon.
Ya, saya ingatkan sekali lagi, Bapak Ibu di ruang Zoom maupun live YouTube yang belum absen, maaf tadi agak sedikit telat nge-share absennya. Mungkin Bapak Ibu yang lupa absen bisa absen terlebih dahulu sebelum acara kami akhiri. Absen sudah tertera di kolom chat.
Ya, saya sayonara.
Okay, I think that's enough for today's event. Thank you. Good afternoon. Have a good rest.